Well, hi, good morning. Thank you so much for joining me in my shop here on June 5th. It'll be day 2 with this radio. I think today what I'd like to do is something I often delay, but I think I'm going to do it right now. Let's test all these tubes that are in here. 1, 2, 3, 4, and then we've got these two that are in shields. Yeah, I think that's what I'm going to do. Okay, let's start. Okay, taking the dust off them and decided I would start with this one because somebody wrote 6H6 question mark. And here's the tube that was in there, and it says on it Jan 6H6 GT. So I've never seen a 6H6 in glass form. The ones I've seen are little short metal ones. The Jan part means Joint Army Navy, which means this tube meets the requirements of the American military, or did meet the requirements of the American military. So interesting to look inside there. A 6H6 is a dual rectifier is what it is, 2 rectifiers. So let's start with this guy. Why not? Okay, so I'm going to be doing the testing here with this tube tester. This is a Weston Tubechecker model 981 type 1. It's got a long name. Okay, so it's a little hard to see the dial, but I'll switch the lighting here and I'll try to make that work a little better. Why don't we take a close peek at this tube? So you can see that there's really 2 separate pieces, 2 identical but separate sides to it. It's really 2 tubes in one. And there we are. Interesting looking. Okay, first tube. So this tube is the detector tube, and its job is to, it's hard to say, recover, create, enable the audio side of the radio signal to be separated from the radio side, so the audio side can be sent to the speaker. Okay, let's double check our settings here. 6H6, 6.3, the number is 2731P, 2731P. I've set this up obviously already, so I'm double checking. 06K0, 06K0. Okay, and 39. Plate is set to A. So during the test, we test one half the tube, flip a couple switches, and test the other half of the tube. The switches we're flipping: P1, K1, P1, P1, K1. Okay, it's ready to go. Now, based on the way the radio performed, I really don't expect any of these tubes to be duds. But they could be weak. We could find something weak. Now, testing a diode, all it has to do is come up past this little indicator here, which you can't really see on the camera, but right where my finger is an area that says diodes OK. So anything above where my finger is, it's thumbs up. To test the diodes, we push this test switch. But first, we gotta look for shorts. Any shorts in this tube? If there's a short, the meter will come way up, but there isn't. No shorts in the tube. There goes the test. Okay, and so it clears that minimum amount quite nicely. And we switch to P1, K1, or P2, K2, and try it again. You see, both diodes are in very good shape. Excellent. So this tube cannot be causing a problem in the radio. That would be my impression of the situation. We'll put it back in. Now, next tube we'll test is a 6K6. Yeah, 6K6. This is the tube whose job it is to amplify the signal that's feeding the speaker. So this is what powers the speaker. So this tube will work hard in the radio, harder than other tubes, and potentially wear out sooner. 6K6. Okay, so let me set this up and we'll we'll test it. So this test is really done quite differently with the tube tester. This is a dynamic tester or a mutual conductance tester or a trans conductance tester. There's a number of words for it. The first test basically was just a simple test to see if the tube would conduct electricity properly. The first tube I did, but this one's different. This is an amplifier tube. It has a characteristic that's commonly called transconductance, or other names as I mentioned. And this guy is going to try to measure the transconductance. And that way we can tell if this is working good as an amplifier or not. It's not just a question of whether it can pass current. So we're double checking here, 6.3, signal level 2, bias set to 46 high. The numbers are 07345, 07345, 061, 0610, 0610. The easiest way to make a mistake with these tube testers, and I do it regularly, and you see how I'm keeping my finger down here? It's so easy to start reading the wrong line and set the tube tester up half for the tube you're interested in and half for the next tube on the list by accident. It's really easy to do that. So that's why I'm trying to be as careful as possible and not do that. We should be on F, 44 here, yeah. Okay. This tube tester says this test should result in a scale reading of 1300. So 1300, well, this is 1500 in the middle, 3000 at the top. So 1300 is just back here. That's the reject point. If it comes up this high, it's garbage. It's got to come up higher to be a good tube. So I don't see the element going, but again, we heard this radio, so it must work. Looking for shorts first. No shorts appearing. So now we're ready to test with the GM test button. Here we go. Way over. Big thumbs up on this tube. So that's good because the output tubes are commonly very weak. Okay, next logical thing to do, I'm just going to pull it out of the radio here. There's two of these. 6C5 tubes. These are amplifier tubes also. 6C5. Okay, I'll set the tube tester up and then you can help me double check. Okay, ready now for the double check. 6C5. Signal level 2. Bias level 20 high. 20 high. The numbers are 27305, 27305, and the same as the last one, 0610, 0610, 43. This adjustment is the meter sensitivity, and I call it the cheater adjustment because based on the setting where this is, the meter goes up or down higher. So the designers would use this number to compensate for and to try to get the reading up kind of in the middle of the tube here. Is that crap? That's probably crap what I just said. 43. F. 1300. That's the same number. That's it. That's surprising. Okay. Here we go. So as I mentioned, this is also an amplifier tube, so we'll be doing a GM test on it. GM is the code for transconductance or mutual conductance. Okay, let's go. Any shorts in here? Part of doing the short test is to protect the tube tester. A shorted tube can do damage to a tube tester. 1300, same thing. 1500 right straight up, so 1300 about here. Wow, she's a big winner. Now, we have another one of these. All these tubes are testing very good so far. Another one. 6C5. Okay, in you go. Give it a moment to warm up. shorts. Sometimes people will whack the tube with their finger to try to initiate the short, thinking the short is in there, it's just not appearing. You want to whack it. I don't do that myself. So here we go. Again, 1300, same thing. Here we go. She's another winner. Good tubes in this radio. Now we're down to some difficult ones here. Well, not difficult, but a little more problematic. So these ones have grid caps on them. I'm going to take off the grid cap. Pull the shield off. There's the tube. Okay. This is a tough one to wiggle out. It's got a fitting around the bottom here. That's. There we go. 6K7 GT. So the words are here. I don't want to wipe it where the words are. And the odd tube, the words are written around the top here too. You really want to avoid wiping on that area. And you notice the base is loose. So that's not critical in the operation of the tube unless it's really, really loose or it's been spun. But what they do is they glue this base to the glass and the glue is given out. So it's okay, I just need to make sure be gentle with it. 6K7, made in Canada. Okay, I'm going to set up the tube tester and we'll let her rip. Okay, let's double check what I did here. 6K6, 6.3, signal level 2, bias is 46. Oh, wait a minute, am I reading the right one? Wait a minute. In 6K7, I started reading the wrong line. 6K7 is 33L. 33L, correct? 17342, 17342, and 0610, 43 D. 1070, so this one should be just above the 1000 mark here. It has a grid cap on it which we must connect. Connect with the grid. There. Give it a moment to warm up. Here we go. Okay, this one should 6K7. I already said it, 1070, so just above here. Very good. That's a good thing. These tubes are a little more rare. See, it only has 3 letters, 6K7. It's the later version of this was the 6SK7. It has more pins on the bottom, has a different base, more pins on the bottom, and they got rid of the grid cap on the top. And the S stands for single-ended. This is a double-ended tube. It has terminals on both ends. So 6SK7 is a 6K7, but in a single-ended format. There we go. That was probably pretty exciting, wasn't it? Know that. Okay, I'll put this back in. Now, next tube. Let's pop it out here. This one's got an interesting shield on it. So let's take a look at this. The shield is shaped just like the tube. Then this one's kind of just a drab. This one's got a real, I guess you could say, sexy shape to it. Now usually they have a clamp fitting on it. Maybe I should have left this tube out. You pull the whole tube out. Not a good idea. I'm going to push the clamp down here. This little clip. Try anyway. Can't do it. There it goes. Okay, so let's push that off. This thing will separate and come apart. I'll pull the grid cap off. There we go. Pull the tube out at this point. Rather not, considering the other one had a loose base. Maybe this one does too. Oh my gosh, that's got the solder wire on it. I forgot about it. That's why I'm having trouble getting it off. Goat, G-O-A-T, Goat, New York. Is there a place in New York named Goat? Really? Just Goat? Yeah. Wow. What's Goat, New York famous for? Shields for vacuum tubes. That's okay. I grew up in a town that made baskets for fruit baskets, bushel baskets, 11-quart baskets, all those things. That was the heavy industry in my town. So this looks like it's a 6A. I would think it's a 6A8 myself. Let's take a look at this. 6A8E. I'm not sure the E is important. Okay, is the base loose? No, base is still glued on. When renewing, install a genuine Philco tube. Yes, sir. Okay, 6A8. Let's put this guy to the test. Okay, we're ready for the double check here. 6A8, 6.3, signal level 1, 20L. 20L for the bias. 27345. 27345. 4610. 4610. 32. C. 720. Grid cap. In we go. Grid cap. Okay, here we go. Any shorts in you? No. Shorts. This one, the reject point is 750, so just to here. It's only gonna make it there. 750. Way muhaha. That's my excited response. Very good. That's all the tubes in this radio. So we know the radio's behavior and misbehavior cannot be because of a tube. You know, this is very typically a very early thing to do when you start working on radios, of course. Hey, are the tubes okay? But sometimes I actually delay this for quite a ways into the process. I'm not going to put the shields back on for now because I'm probably going to want to maybe pull the tube out again later. So I'm just going to leave it like this. Without these shields, the radio may not work well at all. So we can't. You know, in order to really properly test the radio, we have to have the shields back on. But that's not what we're doing right now. I think that's going to be it for today. It's another beautiful day outside. Where is the rain? There's been no rain here for a couple or 3 weeks now, really. It's just, everything's going dry. And there are forest fires, nowhere near where I live, but forest fires hundreds of miles from here, or even thousands of miles from here. And the smoke from them is significant enough that the sky is got this weird look to it, like it's cloudy, but not. It just doesn't look like clouds. It's strange. You look up, it's kind of a whitish. It's smoke. It's smoke in the sky. Consequently, my burgeoning astronomy career is on hold because the sky is just not dark enough at night. So anyway, that's it for today. I hope tomorrow to have the schematic and have some information about this, we can start looking at what did the previous guy actually do with this. I think we can guess, but it'd be better to have the schematic and kind of work it out. So thanks a lot for watching, and see you later.